I need to talk about heat itself, which is really equal molecular motion. When we heat something, we are not adding heat per se to substance, we're increasing its molecular motion. Once we understand this concept, microwaves become a lot safer and easier to understand. So once our hand approaches a very hot object, the hot object has very fast moving molecular motion. Our hand skin doesn't have as fast moving. So when they get together, the molecules of the heat impacts the molecules of the skin and makes it go faster. And of course, the nerve endings sense that and we feel the burn. The same thing could be the opposite. At cold temperature, we can have frost bites because now our skin is moving faster, the molecules, and then the air temperature has a slower moving molecules, and we have the opposite effect. So we have to understand that heating is really increasing the molecular motion of the molecules, and that is why microwaves are so much more efficient, because microwaves directly excite the molecules of the products to heat, whereas in conventional steam heating, we have to first create the heat, create the steam, transfer it to the jackets, heat up the walls, and then transfer it to the interior of the product, to the product inside the tank. And that is not very efficient. We have a few minutes for question and answers, and I've already got a question here asking about, let's see, how practical are microwave waveguides inside a sanitary food processing environment? This is a very important question. Waveguides are typically made of aluminum or copper, and they are sometimes, or most often, they're painted as well. We know that these are not very much encouraged in the food industry, so Wavetek has basically embarked on the idea of using stainless steel waveguides. So we have waveguides that are either 316 or 304 choice for use, so they can be power washed for cleaning and wash down. One other aspect to the waveguides is that there are advances in microwave generators nowadays, and these advances include the development of what is called a remote magnetron head, where the magnetron head itself is installed on a short waveguide attached to the vessel. And from there, cables run into another place away from the washdown area and will be attached to the controller. So in that case, it's really the best of both worlds. We're going to have microwave generation and cooking vessels without the waveguides overhead, and in the way making washdown a lot easier. We have time for one more question. And any question that we don't get to answer, we will answer later on. And since this webinar is recorded, it'll be posted on our website. The second question is, are magnetrons considered consumable components, and how does that affect long-term economics? Magnetrons are considered consumables, and it depends on how extensively we use them. For example, on 100 kilowatt microwaves, we normally try to use it at 90 to 95 kilowatt and not at max 100. And in the past, when we ran a 75 kilowatt microwave 3 days a week to make lubricating grease, we ended up running it for about 2,000 to 3,000 hours before we had to change the magnetron. Magnetrons are reasonably inexpensive, but like the light bulbs or vacuum tubes, they get tired and they don't generate as much electrons when high voltages are applied to them, and they need to be replaced. The good news is that although expensive, there are solid state microwave generators that are coming online. Those, just like the current solid state televisions, they can run 50 to 100,000 hours. They are very expensive, but at this time, magnetron-based generators can be used effectively, and depending on the intensity of use, they have to be changed every so often. But we're advancing rapidly, and I'm sure in time the prices will be more economical for the solid state microwave generators. With that, I thank everyone for attending, and we'll say so long.